So I believe you have tried the exercise, and let's solve it together now. Now let's take a quick look at scalar multiplication of vector form, and we will recall that if we have R, or let's call this X, it has A and B components. If we have 2A, the result will be 2 multiplied by A, 2 multiplied by B, which will be 2A, 2B in the X and Y respectively. So therefore, if I have X, if I convert this to component form in unit vector, so that will be AI plus BJ, and 2A. Okay, if I convert this in terms of unit form, it will give me 2. This is 2x rather. This also is 2x. So it will give me 2AI plus 2BJ. Because if I multiply 2x here, it will give me 2 multiplied by 2AI plus BJ, and it will give me this. So we can see now that it's basically the same principle, and we just have to apply that in the exercise. All right, so now let's begin on question 1. We are asked to evaluate 2A plus 3B minus C. So let's substitute our values or our vectors. So that's 2A into minus I plus 3J plus 3K plus B plus 3 into B, which is 2I minus 3J plus 5K minus C, which is 5I minus 2J. So let's multiply out and open the brackets respectively. So we have minus 2I here plus 6J plus 6K, and likewise we have plus 6I. Okay, we're using 3 to multiply 2I minus 3J plus 5K, and then we have 6I minus 9J plus 15K, and let's use minus 1. Okay, as case may be, is minus 1, so this will result into minus 5I plus 2J. Now the next thing to do is, now it has been resolved to addition and subtraction, so all we have to do is just to collect like terms. So let's start with I components, minus 2I plus 6I and minus 5I, minus 2I plus 6I minus 5I. And moving on to the J component, 6J minus 9J plus 2J. So we have plus 6J minus 9J plus 2J. And finally, the K component, we have plus 6K and plus 15K. So we have plus 6K plus 15K. So let's resolve this together now. So we have minus 2 plus 6 minus 5. That's for the I component. Minus 2I plus 6I minus 5I. And if we resolve this, we'll have minus I or minus 1J. Minus 1I. Let's resolve 6 minus 9 plus 2 in J. And this also will still give us minus 1J. And finally, we have 6 plus 15. That's in the K component, and that will give us 21K. So we can resolve this and conclude that 2A plus 3B minus C is equals to minus I minus J plus 21K, which I believe we got correctly. Now let's move on to question number 2. We have A minus 2B plus 4C. A minus 2B plus 4C. What is our A? Our A in the question is minus I plus 3J, minus I plus 3J plus 3K. And our B in the question, okay, is 2I minus 3J plus 5K, which you also have here 2I minus 3J plus 5K. And finally, our C which we have in the question, is 5i minus 2j. So we have 5i minus 2j. So all we just have to do again is to open up the brackets with scalar multiplication, and we add and subtract the coefficients respectively. So this will result into minus I plus 3j plus 3k. Let's open the brackets. That's 2i minus 3j plus 5k with minus 2, and this will result into minus 4i plus 6j, all right, minus 10k. And let's resolve, open this with positive 4, and this will result into 20i minus 8j. Now with that done, let's evaluate the corresponding terms. Minus I minus 4i, and we have 20i. So this results minus I minus 4i and plus 20i. Next is the j component, 3j plus 6j minus 8j plus 3j plus 6j minus 8j. And finally the k component, that will give us plus 3k minus 10k plus 3k minus 10k. So let's simplify now, and this will result into 15i. Okay, the j component will be equated to give us j plus 1j, and the k component, okay, that's 3k minus 10k, will give us minus 7k. So we can come to a conclusion that a minus 2b plus 4c is equals to 15i plus j minus 7k, which I believe we got correctly. Let's move on to the last question, which is question 3. The question says we should evaluate a minus b minus 3c. A minus b minus 3c. So let's simplify it together now. A in the question is minus I plus 3j plus 3k, minus I plus 3j plus 3k. Our b is 2i, okay, minus 3j plus 5k, and our c is 5i minus 2j, 5i minus 2j. So let's open up the brackets, and this will result into minus I plus 3j plus 3k. We open up this with negative 1, so this will give us minus 2i plus 3j and minus 5k. And finally we open up this with minus 3, so this will result into minus 15i plus 6j. Now the next thing to do is to like terms, collect like terms. So this is minus I minus 2i minus 15i. So we have minus I minus 2i and minus 15i. Moving on to the j component, 3j plus 3j plus 6k. So we have plus 3j plus 3j plus 6j. And next on the line is the k component, which is 3k plus 3k minus 5k minus 5k. So let's resolve everything together now, and we have minus I minus 2i minus 15i. This will give us minus 18i. The j component, which is 3j plus 3j plus 6j, will give us 12j. And likewise the k component, which is 3k minus 5k, and this will give us minus 2k. So we can come to a conclusion that a minus b minus 3c is equals to minus 18i plus 12j minus 2k. So we can see how scalar multiplication, okay, is being implemented into addition and subtraction of vectors in their component form.